So I want to take a moment to talk about mineral maturity. You've just spent quite a few slides looking at sand. Now I know sand may not be the most exciting topic to talk about, but it can tell us a lot about the maturity of the minerals. So as you learned, we have four basic types of sandstones. We have our quartz sandstone, we have our arkose, we have our gray wacky, which is just a fun word to say, and we have our lithic. So we generically have four different types of sandstone, and we break them apart by looking at the amount of quartz in them, or the mineral content. So in a quartz sandstone, we find predominantly quartz. That shouldn't be a shocker. In our arkose, we find lots of quartz, but what we also find is there's usually about 25% feldspar. Now, in our gray wackies, what we tend to find is the gray wacky is quartz, it's got sand, but it also has mud and clay mixed in. And that's why it's called a gray wacky, because it actually looks gray, right, from the mud and the clay. And the lithic, okay, what we tend to have here is we have a mixture of different things. That's all going to depend on the environment. Now you might say, okay, well, what does this tell me? Why is this important? So if we go back to the previous chapter, we talked about the origin of sediment and where sandstone, or where quartz comes from and why it's important. So if you remember back to that lecture in one of our Let's Take moments, I said that quartz is a very, very hard, durable mineral. Remember, it doesn't really break down during the erosion process. We talked about granite breaking down into feldspars and quartz and biotite and amphiboles, and most everything turns into clay except for quartz. So what that should tell you is the more quartz we have in a sand or in any type of rock, the more mature it is. So what I mean by mature is it's been around for a long time. So the longer it's been around, that means the higher the percentage of quartz. So when we see those different types of sandstones that we just talked about a second ago, we can kind of plot them out on where we should expect to see them. So let's just say, and this is going to be highly exaggerated, here I have the mountains, and it's going to grade down, and then we're going to move out to the ocean. Right? So say here's the ocean. Okay. So our most mature rock that we had there was our quartz sandstone. So when we find a quartz sandstone that's predominantly quartz, that tells us it has traveled a very far distance. It is very far from where it originally started. Now remember, most of our rocks are going to start here in the mountains. So here's our start. And remember, our mountains are mainly going to be composed of granite, as we talked about. So if I find a quartz sandstone, right, I'm expecting it to have been through the system a lot. The water has beaten on it and beaten all the other minerals out. So I'm going to find my quartz sandstone at the beach. If I find that arkose, it has a little bit of feldspar in it, which means it all hasn't undergone hydrolysis. Well, we're not quite there yet. We're not quite out at the beach. Okay, when I find, say, our lithics, I might find my lithic up in here, right, where it's just got a bunch of different kinds of rocks mixed in. Our gray wackies we tend to find out in our deltas, okay, so that has a lot of different stuff, okay, mixed into it. So why this is important is anytime we see quartz, like I said, a high amount of quartz, I know it is far from the source. So when we go back in time and we look at, say, let's say I find a quartz sandstone in the middle of Ohio. Well, I know that quartz sandstone had to have come from somewhere, and it actually traveled a very far distance to get there. So if we're going to be working on taking a look at different environments and how to interpret those environments, well, I have to look for those subtle clues. So really relying on quartz as an indicator of maturity is actually quite important.